Hi, everybody, and welcome to yet another Zoom interview, this time with Washington Geological Survey field geologist Andrew Sadowski. Andrew, what's the weather like today in Ellensburg, Washington?
Thanks for having me on your program, Nick. It's pretty cold. It's in the
It is
20.
pretty cold. Yes, full disclosure, Andrew is just a few doors down from me on the first floor, Discovery Hall. So we have to stick with the format and ask about the question. But we want to get right into this, Andrew. And viewers, this is the third of three consecutive Zoom interviews asking the question, did the Columbia River basalts ever cross the Cascade Mountains at some point in the past? And who better to ask than this guy, Andrew Sadowski, who's done some detailed mapping of the CRBs, the Columbia River basalts in southwestern Washington, and more recently on this side of the mountains in central Washington. Maybe verbally we start, Andrew. What did you think about those two conversations with Sky Cooley and with Lydia Steisch? Are these crazy things we're talking about, or have you been thinking about some of this stuff too?
Yeah. Well, I liked both of those videos. I mean, I talked to Sky and Lydia pretty professionally, and we've been on field trips together, and so it's a pretty like friendly, camaraderie relationship.
Yeah.
Uh, so yeah, I don't think anybody's out to lunch, and I think Lydia has kind of put out some very compelling data with her kind of plot from I think this was a field trip guide from Jim O'Connor in the like 2021 or something like that. Arc versus River. Very cool like set of publications. So worth definitely worth looking at in more detail. And likewise, Sky, I think Sky's kind of hit on a lot of really cool outcrops that, can kind of help tell this story in more detail, like regionally. I will kind of put myself down a little bit. Like my expertise is um I don't know how to put this, but like I get really focused on my map area and I really don't address some of like the bigger regional questions all at once the way like Lydia and the Federal Survey and Sky do, which is really awesome. And I feel like I am kind of not pigeonholed, but like I have a pretty, clear focus. And so like it's really great to see the work that other folks do to kind of break me out of that little map area or like the postage stamps. Um,
That's great. I mean, that's your job. Your job is assigned to map at a particular scale and to create these beautiful maps in cross section and text and other things. So let's go to that. Where do you want to start? We want to start. You're working on the west side or the east side of the Cascades?
yeah, I guess we could do this kind of chronologically. So
For you, your work.
yeah,
Yeah.
chronologically for my work, I started at
Yeah.
the WGS in 2017, and I was mapping kind of in the I-5 corridor. The name of the map area was called the Centralia Quadrangle. This is about 50 square miles. And my second map after that was the westward adjacent one, Adna. So you're kind of following the Chehalis River upstream. And at this point, the Chehalis River is kind of flowing from west to east and then south to north before it takes that bend around.
Okay. Mhm.
Um, these two maps, and then in 2019 is when I came out to Ellensburg and Central Washington University. So the motivation for these projects were to kind of like look at seismic hazard associated with the Doty Fault and some of those structures in Southwest Washington and the Willapa Hills and the Chehalis Basin. So like I just started like getting my feet wet in Washington geology in 2017, 2018, before coming out here and then like really diving into the CRBs. So it's kind of neat and it's caused me to like look back on that mapping that I did with the kind of knowledge that I have today. And that's kind of what we're going to talk about. So I can share the maps now, or I don't know, what would you?
Let's have you share, and while you share, I'll just talk to the viewers. Yeah, so we're starting with southwestern Washington. We're south of Seattle. We're west of the Cascades, and Andrew is showing up, starting to map in southwestern Washington around Centralia. And part of his mapping includes these Columbia River, these flood basalts, which had their origin east of the Cascades. But as Andrew says, he's down to this scale and he's not thinking a whole lot about big, broad, cartoonish thoughts necessarily. So, which colors and which units are we talking about with our key CRBs today, Andrew?
Yeah, so they're pretty like sparse on the map. So this is the Centralia Quad, kind of guiding the readers or the viewer's eye. Like this is the I-5 corridor right here.
Mm-hmm.
Town of Chehalis is down here. Town of Centralia is up here.
Thank you.
You're really looking at this kind of brownish color here. This
Okay.
is, maybe one of the few CRB outcrops, areas that we found in this map area. A lot
Hmm.
of the other kind of blues and greens here are Eocene sedimentary rocks and Oligocene sedimentary rocks. So your viewers are familiar with like the Lincoln Creek marine unit, and then underneath that, the Skookumchuck, which is a Eocene nearshore sedimentary rock. A lot of mica, and it's carbonaceous. So it's coal bearing too. So a lot of the
Okay.
coal are farther north off the map area. This is the western adjacent quad, the Adna quad, and the CRBs again are this kind of brown. This hill down in here, the edge of it's over here. This is New Wacom Hill. And so you've got kind of a set of folds over here. I will admit some of these folds these are the pink lines, are from the geophysics, which I support, but I maybe shouldn't have put them on the map the way I did. I won't get into the wonky details of that. But basically, the CRBs are located here, and there's even a few spots closer to the Doty Fault, which is kind of cutting through the map area about here. And this large area here is an uplift, caused by the Doty Fault.
Okay. Were you the first to map the CRBs on these two map areas, or did you just confirm those Grand Rondes were there?
That's a good question. Some of the mapping was done by Snavely and others in 1958. That particularly this map over here, I think it was a 100K map, but it might be more detailed than that. And then Pease and Hoover also mapped some Miocene volcanic rocks. And that was kind of in the also like the 50s. So I don't know if they were necessarily recognized as CRB at the time, but they were
Hmm.
recognized as Miocene and not crescent, because there is crescent kind of flooring a lot of the area around here.
Can you stop your share? This feels like a big moment right away.
Yeah.
How do you tell the difference between Siletzia crescent basalt and CRB basalt? Can you do it in hand sample, or do you really have to send every sample in for geochemistry to confirm that some of those basalts erupted in eastern Washington versus the others that erupted out in the Pacific Ocean?
That's a tricky question. I'll make a joke after, but stratigraphic, position, if you're not necessarily around a lot of faults and you're pretty confident that you're in the Miocene somewhere and you encounter a basalt, often I'll kind of lean more towards it being CRB in the field, and then I'll send out the chemistry later to kind of help me confer that. I didn't really see any Siletzia or crescent basalt in the field here, mostly because I wasn't that deep in section. So why would I kind of expect that?
Right.
Um, but also, because this is Western Washington and not Eastern Washington, the amount of weathering that these basalts have experienced is pretty profound, to the point where there was like some really mushy outcrops in that New Wacom Hill area that I was just like, this was basalt. And it was like you could throw a baseball into it and it would just like stick. And it was kind of gross, but I got the hardest part of that was not so gooey, sent that in, and it came back with, a CRB classification. Um,
Okay. Was that your joke, or are we building towards the joke, Andrew?
the joke is the crescent looks older.
Yeah. Okay.
It's like
Very good.
not
Yeah.
not diagnostic at all.
Right.
That's not the way to do it. But it's funny that like it kind of looks that way.
So there you are in the Centralia area. You're mapping more than 5 years ago. You have Columbia River basalt lavas, and you assume that those CRBs flowed through the early version of the Columbia River Gorge and basically flowed up I-5 to get to those locations.
Yeah. Yeah. I mean, that was kind of what I came into. I mean, I was drinking from a fire hose at that point. And so
Right.
there was so much stratigraphy to like get under my belt really quickly. And so that's what I had heard, from the experts who I was working around already that had a lot more experience than I did. And I didn't really question it very specifically. I did wonder, like, I wonder where these pathways are, um, because I was envisioning it more as a channelization rather than like a blanketing across the proto Cascades. Mostly because if there was a blanketing, we would see expressions maybe of these blankets somewhere either in the shallow subsurface or at the surface. And so we're not seeing them at the surface. And what we mostly see are these Eocene and Oligocene rocks, which is like, great. So then maybe the CRBs were wiped out and eroded away. And so we won't see them. But then in the shallow subsurface, that is still maybe like a place to look.
Hmm.
And I started thinking about that more maybe in the last like couple weeks, building up to this. And I started looking in places like Jackson Prairie and, leading up, eastward towards Rife Lake. And, you get a lot of Fife's Peak and a lot of Jeffrey Clayton's work and, kind of slowly approaching Hammond Land, there in the Central Cascades. And I mean, there are a few like Miocene basalts that are probably Cascades related. Um, I'm thinking about Sky's really neat hypothesis about like there's probably a uh, a channel somewhere. Maybe there is. Forgive me, Sky, if I'm like paraphrasing incorrectly, but like somewhere north of the present day Columbia River Gorge and south
Right.
of Snoqualmie Pass. And I've been
Yeah.
thinking about that, and I haven't like I mean I think he's kind of right. Like there isn't sort of like a the intertonguing of material coming from the east there. So to me, I think the Columbia, wherever it was, 16 million years ago is probably, the pathway.
Very good. Thank you. We're going to bounce over to the east side of the Cascades in just a second, but I guess I'll update you, Andrew, and everybody on my thoughts. I've been chewing on this for about a week, and I was initially visualizing a blanket. And that's what, Bates McKee was talking about. That's what J. Hoover Mackin was talking about more than 50 years ago. Truly a blanket, and we had a coastal plain made out of basalt, and then these cascades start rising. I'm off of that too. I've gotten enough emails from Don Swanson, other folks, papers, the Steamboat Mountain thing. We've chased that. So I'm going to present most of this stuff on Thursday of this week, and I'm excited to do that. I am also entertaining this channel idea. And so maybe just verbally before we kind of connect the dots over to Eastern Washington, it is possible in your mind, you don't have to be some, major player here and say for sure, but you could connect the dots through the Cascades on US 12, let's say, some sort of ancestral Lewis River or something like that, crossing the Cascades when the Cascades were low, and somehow connecting between the Grande Ronde lavas near Yakima and the Grande Ronde lavas that you just mapped in Centralia. It's not crazy to say that. Sounds like you were thinking that.
Yeah, I mean, like if I could share my screen again,
Please,
I think
let's do it. Yeah, I mean it's fun to talk to somebody who knows the detail of some of these flows on both sides of the Cascades, and pretty much everybody is saying, besides Steamboat Mountain and a couple other small things, there's nothing there. But this is fun to talk to somebody who's seen these things in place on both sides of the Cascades. Go for it, Andrew.
Yeah, so those two map areas are right over here. So the
Great.
5 corridor,
Yeah.
Centralia, Adna, and I was kind of imagining maybe there's some channel corridor in here.
Yes.
And the place to maybe look for that would be in this area because these kind of QAPO units that are labeled here, these are Quaternary alpine glacial outwash deposits. So these would
Uh-huh.
cover the Miocene rocks. The Jackson Prairie natural gas storage facility is kind of around here too, and they have a lot of deep wells. And so yesterday I kind of looked through some of the well data, hoping to find some CRBs there, and I didn't. Like this first 100 feet is what they call like basin fill, and then they get into the Lincoln Creek and Skookumchuck.
Huh.
Uh, so maybe you could argue, oh, okay, in those first 500 feet, maybe they hit a little thin bit of basalt and didn't bother recording it. Or if it's really channelized, it's kind of like hitting a dartboard, and they would have had to hit the
Hmm.
well just right to get that subsurface basalt. Um, all these polygons here are CRBs that are outlined. And so
Wow.
like the two areas that I was kind of talking about were like over here. And this CRB actually strings along in the footwall of the Doty Fault over here before taking a pretty sharp bend. There's a CRB over here also that's far younger. So this is the Pomona flow that Lydia was talking about.
Oh yeah.
All, there's other CRBs here. And what I've highlighted is the N2 of the Grande Ronde, so the youngest part. of the Grande Ronde, I should say. And then one last thing, and I'll kind of throw it back to you.
Yeah.
The one of the things that I learned in the last, few years, working with the CRBs out east, is that I took another look at the chemistry that I had collected those first couple of years, and other people have collected the first couple of years, to see exactly what flows are there. On the east side where we are now, there's a whole, set of package of flows that, it's
Right.
pretty thick and you can map them out, you can use the chemistry, etc. What we're seeing over here is really like only one type of chemistry of the flows in the Grande Ronde, which is the McCoy Canyon, which is like a subset of the Sentinel Bluffs. And I won't
Ah,
through too much jargon, at you, but like Sentinel Bluffs is like, kind of thick, maybe like 500 feet-ish thick. The McCoy is probably like, a fraction of that, maybe a quarter of that or less. And that's all we see over here. So I've wondered if, the R2, the older basalts, the thicker ones that we see, out east, literally and figuratively laid the groundwork or paved the way for the McCoy Canyon flow to like make it out this far. And then later the Pomona flow, which isn't highlighted, but it's kind of over here.
okay. We're going to come right back to this map, but can you stop your share for a second? I need to see you just for a sec. So the detail, I was hoping we'd go here. So within the okay. So viewers, the German chocolate cake in its middle is 3 miles thick. Those are the Columbia River basalt lavas, and I'm going to be calling them the Yakima basalts on Thursday. So there's 300 layers. But each layer of the 300 layer cake is not the same thickness. It's not the same flow. And we'll look at that on Thursday. So within the Grande Ronde, those are the monster flows. And now Andrew is saying within the Grande Ronde monster flows, some are really monsters and some are much less as far as volume is concerned. What's the biggest of all the Grande Ronde flows? Is it that Wapshilla thing?
Yep. Yeah. The Wapshilla Ridge is the big one. That was, I think we were talking about this in the field a while ago back, about like 40% of the eruptive volume. I might have that wrong, but look at the
More,
previous video. I said it right.
yeah, more than a quarter of this entire cake is one flow, and we're not talking about that today, or are we?
No, we're not. Like that
We,
is not exposed to the surface this, in Western Washington. We do see it, maybe even touching the Eocene at the bottom, of the stack. So like Ellensburg's over, well, I'm not sharing my screen anymore, but we can see the bottom of the Wapshilla Ridge north of Ellensburg.
if the Wapshilla was the monster, the monster of the monster, why wouldn't it be the one to cross the Cascades?
I mean, it is in the Columbia River Gorge also. So, I mean, this is kind of an argument to say that, maybe the Columbia River Gorge or the Columbia River Gorge was probably, the conduit or
Yeah,
the pathway that was filled in by the
yeah.
monsters. And then, only what's left kind of makes it up into the areas that I was showing on my screen.
But it's kind of the point you just said before I rudely had you stop your share. These earlier big flows are paving the way. They're building a ramp essentially to finally cross over these low cascades. It's kind of what you're saying.
Yeah, yeah. And maybe like the lowest spot in the low Cascades is what these basalts are really trying to get through. Like, I mean, it'd have to be monstrous to really overtop, something. And I think parts of them are, but it's like you've also got faulting that's happening at the same time. I mean, to bring in some tectonics into this, like,
Hmm.
you've got fault blocks that are dropping down. And if you can imagine, like, you're trying to fill a bathtub and the bottom of the bathtub keeps going down, like you're not going to fill that bathtub as fast. So it's like the monsters are keeping up with that, downward. And then only
Yeah.
a little bit of what's left is really what's going to make it out. At least that's kind
Okay.
of thinking.
All right. Well, this is fun. So let's go back to your map and and thank you for highlighting, outlining in red. That's really helpful for these flows. So when we get back to your map, can you connect the dots in southwestern Washington where you know the flows, and can we see exactly where those same flows are on our side of the mountains? Do you have that level of detail on that map?
Um,
If
I,
not, it's no big deal. Let's just go back to your red outline thing.
yeah,
That
I'll
was
come
that
back to
was
that outline.
we
And
could we
I'll,
could
I'll
we could
I'll zoom out a tad too.
okay.
But it's taking a second to load. So let me.
What's with the internet at Central Washington University? Just kidding. We've got pretty fast speeds here, so we can blame it on something else.
Okay, let me pull this up. Okay, so still highlighted, still outlined, kind of same
Good.
as before.
Can you get us, before you do anything with zooming, can you get us oriented on the east side or the right side of your frame? I see Mount Rainier. What are some other
Yeah.
landmarks?
Kittitas Valley's over here. La Rainier was what you were saying. Mount Howe
Yes,
here. Mount St.
thank
Helens
you.
here. I don't have the Columbia River's just to the south of this.
That's fine. Yeah, and so I've been using Divide Ridge as a landmark that we will talk about on Thursday. Is that where's Rimrock Lake? Can I find
Rimrock, I think, is here.
yes, yes. Okay, good. So there's a hell of a lot of these flood basalts outlined in red, MVGN2. And you've been, maybe this is the time, Andrew. Where have you been mapping the last 2 or 3 years?
Over
On,
here.
yes,
So kind of like the southeastern portion of Kittitas Valley and now the southern portion of Kittitas Valley near Menashe Ridge.
great,
So
great.
I mean, really, we're looking at some of the younger parts of the Grande Ronde.
Okay,
You see the older parts of the Grande Ronde in the north. So we've kind of been slowly moving up section as we've kind of made it to the second or the southern part of the valley.
okay. Well, I don't know, but before you do anything more with this map, we're connecting the dots right here visually, right? We've got a hell of a lot of Grande Ronde on the right side of the frame. We've got little drabs on the left side. The conventional story is to connect the dots between these two red patches, you've got to go down south through the Columbia River Gorge and come back to the north to the Chehalis area. But it is tantalizing just on this scale to visualize a channel of some sort. And Steamboat Mountain and a couple other tips that we've received are in the neighborhood. It seems like they're a little further south, I guess, huh? Down there.
I think so. The Gifford Pinchot National Forest
Yeah.
is
Okay. Well,
um,
good. What else can you show us in Eastern Washington that might be part of this story today?
yeah. Well, part of the motivation for mapping out in Kittitas County and Kittitas Valley was to see how some of these major faults in the Yakima Fold and Thrust Belt may or may not connect to active structures in the Puget Sound. And so you can
Mhm.
see this kind of long kind of strand of a thick black line there of a fault here.
Yeah.
And here's Menashe Ridge, and there's a fault that kind of almost makes it over there. And it's like I wonder if it actually does make it over there. And that's kind of what we're trying to test, in time,
Mm.
with a lot of different mapping and looking at the CRBs because you can see like this large red area in here is kind of a lot of fine grained basalts, and it's really hard to map out unless you have the chemistry to kind of see the flows and how they change.
Yeah. Well, I mean, I can imagine some of the viewers looking at this and going, "Well, this is cool. I didn't know you could see this kind of map so easily on this guy's computer screen." So we can maybe talk about the portal in just a bit. But the other thing I think people might be visualizing is like, oh, I don't know. Why does this Zentner guy keep pushing this? Like there's a lot of red on the right side, but those things are probably paper thin and they're just wimping out as they approach the Cascades. Au contraire, that's French. Like there's 2,000 vertical feet of this stuff, at least at Divide Ridge, and maybe in your mapping areas as well. How generally thick are the Grande Ronde flows in some of your mapping areas the last couple summers?
Uh, Kind of
Ballpark.
about a ballpark about 1,000 feet. It
Yeah.
pinching out as we move westward, over here. Like, and we've seen that. So that we're talking about the Grande Ronde here. That's what highlighted. But if you look at the next Columbia River Basalt Formation that's younger, the Wanapum, it's
Yeah.
progressively pinching out. This is far less volume. Like these are not the monsters anymore. But you can see
Hmm.
like one unit after another pinch out as you move westward along
Mm.
the Menashe Range front south of Ellensburg.
Mm.
And that's pretty neat to kind of see really clearly. And I wonder if maybe the Grande Ronde below it is maybe doing the same thing.
Interesting. Okay. Can you stop one more time your share? And then maybe with the balance of the time, we'll do a little portal circus here. Um, do you feel like weighing in at all on our timing of the uplift, or where are the structures for the Cascades uplift? Like I keep coming back to that. Like we've got the Yakima fold and thrust belt, which is oriented differently than the main trend of the Cascade uplift. General thoughts on the timing or the structures involved, and are you more on Lydia's end of the spectrum with timing, which is quite young, it seemed, or are you more sky, like 7 million years or even slightly older than that for the initiation of this
Yeah.
major lift of the Cascades?
It's tough. I mean, I think Lydia and the team out of the USGS has put forth like a really compelling argument of this like 4MA kind of uplift story. I mean, I don't think it's necessarily the only story because there might be like different episodes and stages of uplift involved,
Right.
but like I haven't seen as much like compelling evidence for that. I mean, I think there probably is out there. It's out there and I just haven't seen it. And it's like, maybe buried in some of the literature. Um, but yeah, I think like timing and age, like this has been an interesting question, I think, for me, because one of the one of the big challenges when I was starting to work in Southwest Washington was seeing all these different fault orientations that had different senses of slip. Like this side was going up or down, and this was a strike slip fault, and this was a reverse fault, or all these kind of different sets of faults, and trying to put that into like a single cohesive stress regime, because faults only kind of break and rip in one sense of slip when the stresses are in one sense. It's like you hit something with a hammer, it's going to behave this way. But you're seeing things that look like they've been hit with a hammer in a bunch of different ways. Well, you can have that happen if you're in, a state of stress, or the strain field is like very different. I guess it's the stress regime is very different. And so I tried to talk about that in some of my first paper. I won't show that figure because it's a lot, but I've wondered like if the stress regime has changed over time or if it stayed the same. And really just like what's happening is we're getting like one stress regime with different faults getting made, which would be like a transpressional or transtensional stress regime to produce, many of the kind of complicated structures like these north-south anticlines. Why are we seeing those when most of the Yakima folds are east-west?
Yeah.
And there's a rotation there too, but like, I don't know. It's these are big picture questions that like I'm often like, all right, I don't have time to address them, and I should probably think
Yep.
about them more, but I'm doing
That's
all
right. That's right. No, you're drilling down, and we may have you do this again with me in a week or two if you don't mind. I'm springing this on you now because we're going to be talking about the Ellensburg Formation and the sedimentary units between. I'm not quite sure how much I'm going to do with that, but we might start thinking about some of those inner beds. How about one final thing verbally, and then let's play with the portal for just a second. Um, What are your most current dates for the end of the Grande Ronde time? Like it feels like a generation ago, I was always teaching the Grande Ronde starts 16 million years ago and it ends 15.6 million years ago. I still have that committed to memory from work that was done 40, 50 years ago. And then Jennifer Kasbaum and some of these Princeton folks are showing up and they say, look, we've got these dates from between the CRBs that we can date quite well. And we now like the Grande Ronde to start 16.5, I think, and ending 16.1. Is that roughly where you are with your dates that you have?
Yeah, kind of. I mean, like their methodology is very sound and super precise because they used, a very precise method. And the method that I've used for my dates is not as precise, but it kind of more or less agrees with some of those major ages. Well, it does agree. But to your point, your question about like, well, when's the end of the Grande Ronde? So what I've used for that is the Vantage. Like the Vantage sandstone is an interbed between the Grande Ronde and the Wanapum. And so imagine an Oreo cookie, and the Vantage is that cream between the basalts, the brownie cookie basalts. I got about 15.96, but again, that's with my like imprecise ages. The age that Kasbaum and Cheney got was, very good, but it was like still, very close to that, like around, 15, like late 15, like very early 16. And it should be said that like this was an eruptive age for a tuff at the very top of the vantage. So it wasn't like a detrital zircon or anything like this. Like, and it's kind of funny. Like you don't think like, why would there be a tuff, or like I wouldn't expect there to be a tuff in this sandstone. Well, breaking out the vantage into like a bunch of different facies, is possible
Hmm.
depending on where you are.
So what's Jennifer's date and your date for that tuff at the top of the vantage? Did you both sample the same thing from the top of the vantage?
I don't think we sampled the same thing. I think she sampled
Okay.
something else, maybe outside of Kittitas Valley. She said her map area was pretty much like the Columbia Basin at large.
Okay. Okay. But your date one more time for the top of the vantage. Do you have it committed to memory? That tuff at the top of the vantage? 15
Uh,
point.
15.96.
Okay. All right. I'll
Wait,
use it.
wait a
Good.
minute. Well, let me double check. Let me make sure I like reading the right one. Ashy Siltstone. Nope, that was the wrong one. It was 15.95.
Okay. Okay. All right. All right. I love it. I love it. Um, how about 5 more minutes with you? Thank you for your time. Can you introduce us to using the portal, as it's known, from the Washington Geological Survey, and just maybe the first few steps on how to do that, and then we'll maybe do a whole nother video just on that with you or somebody else from the survey.
Okay. Well, I'm here sharing my screen, looking at, just a blank page. I
Yep.
bookmarked the portal, but if you, Google DNR, geology portal, will come up pretty fast.
Thank you.
And you click this button in the middle, and then it takes you to this screen, which is what my shortcut would take me to. But, these first steps kind of are helpful.
Yep.
You say,
And they are.
you finish like the privacy statement thing. It's warning me about low system resources. Um, Probably because I'm talking over the internet and loading this.
Right.
So by default loads to a 500,000 scale surface geological map, just the polygons. What I was showing everybody, and there's a lot to show here, which we won't go through. I usually
Mhm.
load the 100K geology, so the 1 to 100,000 scale. I then wait for the polygons to populate. I then turn on the contacts, the faults, and the folds, and maybe I'll also click this like hamburger button here to turn on the labels. And so, it'll take some time to kind of catch up, but once it's there, you kind of have exactly the map that I was sharing on my screen a second ago.
And how often do you go to the portal as an official employee of the survey?
I mean, probably pretty regularly. I mean, I'd say I use it at least once a day.
Yeah.
It helps
Yeah.
me like, get out of, my map area and look more broader scale at things. I mean, I can
Yes.
bring these same data into like, ArcGIS and other kind of specialty software programs where I can look at it. Um, that involves like a whole different set of steps, but this is just so fast and so convenient. So I'm not trying to, do anything or manipulate any sort of data or like, change things or anything like that. So just viewing it, like we're looking at here, can be done very rapidly, through any internet browser, even on your phone. Although it's a small screen and it helps to have more, screen real estate when looking at this stuff.
Right. Thank you. I think that's a perfect start, and we'll just keep trying with the portal with you and other employees of the survey. If you can, I say goodbye to you by stopping your share one more time. Thank you, Andrew, for doing this. I, I was serious last month when I was over to Olympia with Jordan Carey. I'm like, there's a lot here. People should know about every one of these employees at the survey. And you have plans for the next few years to continue mapping on this side of the mountains. Before we say goodbye to you, what's happening maybe the next couple of summers with your mapping?
Yeah. Well, thanks. I mean, this has been fun to be on the program. Looking ahead, the probably the next quad to the north, so that it's kind of centered on Thorpe, Washington. Maybe it'll kind of I'm kind of get out of the basalts a little bit and looking more at these like Ellensburg Formation, like the White Cliffs, looking at the Pliocene, Thorpe gravel. Maybe there's a relationship. Maybe even seeing some more Quaternary outwash gravels from the Alpine like outwash Cascades or the Cascades Alpine outwashes. So that's kind of what's ahead.
That's exciting. I'm happy to see you get out of those damn basalts and start working with some of these other units. And you've done fine work with the CRBs. And I want to post a couple of your recent maps and pamphlets. So you might give me a couple of your favorites that might go well with Thursday's episode. But let me stop the recording here and we'll chat just a couple more minutes. Hold the line, please. But thank you, Andrew Sadowski, for your time today.